Good morning, everyone. About myself, I am P. Ilayaperumal from Department of Physics, Aranjarana College of Arts and Science, Krishnagiri. Today, we will discuss about the synthesis of zinc oxide nanoparticles by co-precipitation method. The introductions of nanomaterials. The nanomaterials are materials with dimension on the nanoscale that typically between 1 to 100 nanometer. 1 nanometer equal 10 power minus 9 meter. The next, the classification of nanomaterials. There are four types of nanomaterials. The first one, zero dimensional nanomaterials. For example, quantum dots. The quantum dots only x-axis. The second one dimensional nanomaterials. For example, nanotubes and nanowires. The third one, two-dimensional nanomaterials. For example, nanosheets. The third one, three-dimensional nanomaterials. For example, nanocomposites. The nanocomposites obey the three axes, x-axis, y-axis, and z-axis are satisfied. The synthesis of zinc oxide nanopowders. The synthesis of zinc oxide nanoparticles by co-precipitated method. The first 0.1 mole of zinc hydroxide solution was prepared by dissolving zinc acetate within ionized water. The next, the pH of solution was maintained at 8 pH by adding liquid ammonia solution drop and drop wise. The next, the resulting product was filtered and washed with the double distilled water and ethanol units. It became free from impurities. The impurities are removed. Finally, the sample was prepared by the analytical temperature at 300 degrees C at 4 hours in constant temperature. X-rays diffraction. The X-rays diffraction or XRD method. The XRD method, the standard technique for powder photography method. The XRD method analyzes the crystal structure and the crystal size. The zinc oxide crystal hexagonal structure. The powder X-rays diffraction pattern was studied to determine the structure of synthesized nanomaterial zinc oxide. The particle size are 14 nanometer for the analytical temperature at 300 degrees C. The calculate the unit cell parameters A equal to 5.145 Armstrong unit, B equal 5.205 Armstrong unit, and C equal 5.312 Armstrong unit. This graph against degree and different parameters of A, B, C values. The peak values of 0.1 and 1.11, 2,20, 2,11, 202, 022, 220 are the peak are presented in the X-rays diffraction studies. The next studies, Fourier transformer infrared spectroscopy, the FTIR. The FTIR analysis of the functional group of element. FTIR spectrum was annulled temperature at 300 degrees C. The IR spectroscopy was used to learn the surface interaction of the observed water and dynamic symmetry with a gas phase of zinc oxide surface. The frequency shifted and the absorption values were carefully observed to the surface structure of the zinc oxide phase. It is well known as that H2O and CO2 molecules are simple chemistry into the zinc oxide surface so as exposure in the absence. This graph against wave number centimeter minus 1 against the transmittance. The wave number x-axis and the transmissions y-axis, the graph is drawn. The FTR spectrum the present in 500 to 4000 nanometers. This graph finally my sample zinc oxide present in 300 degrees C, the peak value of highest value. The next study is scanning electron microscope, SEM. The molecular of the synthesis nanocrystalline was analyzed by the scanning electron microscope SEM. The SEM find out morphology of crystals. These structures explain SEM analysis. My particle zinc oxide size 14 nanometer. This diagram explain. The particle is very closed, 5 micron meters. The next size, the particle value 5 micron meters. This graph explains the particle size and morphology structure. The conclusions of zinc oxide nanoparticle by co-preparation method. The zinc oxide nanoparticle synthesis by co-preparation method have a invigilators. The sample have been prepared at analytical temperature 300 degrees C. The powder X-rays diffraction pattern of nanocrystalline zinc oxide hexagonal structure with average crystal size in the range of 14 nanometer for temperature at 300 degrees C. The FTIR spectrum, the zinc oxide well known as H2O and CO2 molecules are the simple reaction into the zinc oxide, the surface as soon as exposures of the crystals. Thus the sample synthesis method of the zinc oxide nanoparticle was good sensor applications. Thank you.